Hey everyone, and welcome to another episode of MLOps Coffee Sessions. I'm Vishnu, and I'm joined here, as usual, by Demetrios. Hey Demetrios, how's it going?
What's happening, everybody?
Are you at home? No traveling right now?
I
You're
am
finally at
super
home?
jet lagged. So if there are any mental gaps that happen during this session, you know why.
Yeah, Demetrios is quite the jet-setting traveler these days, but we're glad to have him back on the podcast, back at home, settled in his studio. And today we are joined by a very exciting guest, Slater Victoroff, the CTO and founder of Indico Data. And Slater today is going to talk to us about a couple topics that I'm really interested in, and I think the community at large is really interested in terms of unstructured data, which many of us are in settings where data is actually, not neatly tabular or cleanly defined, but we're somehow supposed to do machine learning on it, let's say image or text. And also multimodal machine learning. There are rarely cases where all the data that you want is in the same format, in the same context. And Slater is going to talk to us a little bit about what that actually, what the research in that field looks like, how Indico is thinking about productionizing it, and tell us a little bit more about how Indico productionizes machine learning. Thanks for joining us, Slater.
Thanks so much for having me. I'm really excited to be here.
Yeah, I'm excited for what's going to be a great coffee session. But first off, before we get to the MLOps stuff that everybody in our community hears a lot about, I hear that you're an MMA fighter or had a MMA career. I'm actually a huge UFC fan. Khabib is my
Nice.
biggest favorite fighter. I just went to the show in MSG actually a couple of weeks ago. Tell us about that.
Yeah, absolutely. And full disclosure, I don't fight right now, so this is kind of Slater of a past life. But growing up, I did a lot of martial arts for kind of several years. I did Yoshikai karate, and I did Taekwondo, and I did some Aikido as well. It was something that was always kind of an important piece for me, right? But never something, with school that I was able to really devote myself to in a serious way. And all through high school, I was doing a lot of these very academic extracurriculars. And for various reasons, I ended up taking a gap year in between high school and college. And my main goal for the gap year was get out of my head, right? What can I really lean into that will help me do that? And martial arts was kind of a really clear thing. It'd been something I'd been doing for my whole life, and it was a great opportunity to dig in a serious way. It was one of the things that I did during my gap year was that I trained, pretty heavily in MMA. I actually went to China for 2 months to study martial arts. And I did a couple of amateur fights, which were great. It was really fun. And then I learned when you go to an engineering school, very few people there are willing to get in a fight. I was always taught it was sort of like a friendly thing. Engineers just as a rule, terrified of getting hit in the face. It's been a little while since I've fought, but it would actually my wife is a third-degree black belt in Taekwondo, and so that was sort of a club that we were in together, sort of our first year. But we're both retired at this point.
That's got to be like the world's most fun hobby. I got to say, world's most fun, interesting hobby, and
It's
for any of you
fun.
who are thinking about writing in with negative feedback to this podcast, do not.
Yeah,
Don't
Slater's
do
wife will come kick your ass.
Yeah, seriously. Okay, all right. So we got a flavor of your journey into MMA, and now I'd actually love to learn a little bit about your journey into machine learning. You started
Absolutely.
Indico a couple years ago now, in the earlier days of machine learning. Tell us about how you got started with that.
Yeah, so I would love to say that it was a meticulously crafted plot, and every step was extremely strategic, but nothing could be further from the truth. So I was very lucky to fall kind of backwards into a very interesting machine learning problem at my first internship, which was roughly trying to classify videos according to this big taxonomy of learning information. It was like K through 12. So, which topics in biology does this video teach you? I didn't actually realize it was a machine learning problem at the time. I ended up getting, lucky with an approach, and my IP ended up being, a part of this patent that got filed for this, really really interesting kind of overall system, which was cool. And at that point, obviously, I knew everything there was to know about machine learning, and I went back to school, and I told one of my professors as much. And I'll never forget these words. This was in 2012. And I said, the war is over, deep learning lost, right? And I was so completely sure of myself, right? I'm starting sophomore year. And then I started doing Kaggle competitions with the person that would go on to become my co-founder, Alec Radford. And it was really interesting because for the first 6 months, I was feeling really good about my traditional techniques, right? And when I say traditional techniques, right, I mean, this is TF-IDF, right? This is logistic regression. This is SVMs. This is, like keyword features, meticulously tweaked here and there with, interesting weighting schemes and stuff. And I was pretty good at that stuff. But deep learning really started to come to its forefront, right? 2012, obviously that's a really, really important year. AlexNet sort of came out and, we started to do these increasingly ambitious Kaggle projects where we were dealing with text and dealing with images. And, I'll never forget, there was the point where just these deep learning techniques raced ahead, right? It felt very, very tangible the second we kind of got, a modern CNN up on one of these problems. And at first I didn't want to accept it. And I went into all of these different research arcs and I did novel research, right? And I really, kind of tried to push the limit of the field. And I succeeded in that and I got some really great results. But I was not capable of beating any of the deep learning techniques, right? And so over the course of sort of the next 3 months after that first, loss, if you will, I dove in, I tried to beat these techniques, and I eventually realized that I couldn't, why I couldn't. And I decided it was a lot more productive to instead figure out how you could take this technology and make it accessible and make it sort of enterprise grade.
Got it. And from that, Indico was born. Is that correct?
That's exactly right.
If you can't beat them,
and it started as exactly. That's exactly right.
Got it. And so I want to talk a little bit about what Indico is actually doing.
Absolutely.
You guys call yourself the Unstructured Data Company. Interesting tagline.
Mm-hmm.
Can you tell us how you define unstructured data and what Indico actually provides in terms of making that data more useful?
Absolutely. And I'll roll back the clock a little bit, right, to where that just ended and kind of craft that arc, because I think it's highly relevant. The key problem that we recognized when it came to using deep learning in an accessible way was training data, fundamentally, right? It requires far too much, right? It is too inaccessible. You don't have 100,000 examples for relevant problems. We were very, very early to a space that has since come to absolutely dominate the field of ML, right, which is transfer learning. So we, just for some reference, I think most people believe that transfer learning with large-scale language models and text kind of started with BERT, which was 2020, something like that. We had our first large-scale language model for text, and language using transfer learning deployed to production in 2015. It was an RNN, transformers didn't exist yet, but, so we've been at kind of that art and science aspect for quite some time. But the thing that's really interesting is about the implications of transfer learning, right? Transfer learning is a very, very broad field. I would kind of argue at this point, if anyone isn't using transfer learning, they're kind of behind the curve. It's just such an amazingly effective technique. However, right, it introduces some interesting constraints, right? Is that actually it's so easy to build these new models, actually then kind of holding them in memory and, how do you provide, 1,000 different models that you might need for some, broader workflow? That becomes a really difficult and tricky problem. And then the thing that's really interesting and powerful is when you can then train these production quality models with 100, 200, 500 even data points, right? You transform it from something that takes a research team and months to something that you can do in an afternoon or a week if you're busy, right? And that really is the core of our platform, right? Is this training harness, if you will, that allows sort of non-technical people, importantly, to create sort of these arbitrary unstructured workflows, right, based on this kind of very, very cutting edge ML.
Got it. That makes a lot of sense. I'm excited to dig into that. One thing I did want to mention is I think it's so cool to hear from you this historical perspective for how and how it sort of contextualizes your journey through ML and even what you do at Indico now, I think, there's just so much to learn from how, machine learning was done, prior to the invention of just like large scale neural networks, because I think there's a lot of techniques that are helpful.
Absolutely. I think some things that are really, really interesting is understanding which techniques have become redundant and which techniques are now more effective, right? Because it's had that approach on both sides, right? On the one hand, right, all of these insane like stemming and lemmatization techniques, right? Absolutely don't use them. Like terrible waste of time now, right? Modern techniques, they'll just take care of that, right? On the flip side, when you look at a lot of the indexing techniques that we use for search engines, those are now amazingly useful because suddenly you can generate inputs for them that are 10 times better than you could before, representing data in a richer way than you could ever imagine, right? So I think you see both of those, right, where these traditional techniques are now 10 times more powerful, and in other places, maybe more on the traditional data science side where they've become less useful, but it's still helpful to understand what kinds of problems you can run into, right? I think it's helpful context in any case.
So I feel like there's been all these advances in this space, especially with unstructured data. And it feels to me like the adoption of unstructured technologies has remained low. Do you have any ideas for why that is? Is it just still people trying to figure out some very common problems that can be solved with technology and the word hasn't gotten out about it? Or is it because they're even at step 0 and they're trying to figure out how to make machine learning actually valuable for the company?
So as a really, really good question. And maybe just to, I realize I didn't answer Vishnu's earlier question about defining unstructured data, right? So for me, right, unstructured data is, everything that's not rows and columns. So it's text, it's audio, it's image, and it's every combination of those, right? So that means it's video, right? It's documents, which are a really interesting one we can talk about. And all of these other kind of different multimodal pieces. Importantly, I would say unstructured also encompasses where you've got those unstructured sources that are perhaps joined with some structured metadata. So maybe you've got an author on the PDF document, for instance. I'd say that that's still an unstructured use case, or an unstructured document. Okay, so then to talk about why the adoption is tough, right? I think that there's really two key pieces, and the most important one, I think, is this really big knee in technology, right? Is when you look at, there's very clearly easier techniques in ML, right? When you look at, if you have kind of really rigorously laid out forms, for instance, you can make a template that is heavily reliant on XY position there, right? And it's going to work really, really well for that very particular kind of document. Now, the problem is that technique is just really fundamentally different from what you would need to put in place if you were going to, for instance, do sort of a more sophisticated large-scale language modeling technique that actually, uses context and takes advantage of these modern advances on that same document. And that's actually one of the really big rubs, is when you look at the vast majority of people in this space, right, is they are not necessarily very sophisticated on the GPU and infrastructure side of things, right? And their ability to actually tackle and then it's actually funny because there's multiple layers at which unstructured is defined. So there's unstructured, sort of the broad, if you're in the ML space, I think the definition I just used of unstructured is very normal. Like that's just what that term means. Within the unstructured space, if you will, there's a further delineation of structured versus unstructured. That's kind of what I was just talking about, where you then start to refer to these forms that have a static XY position. That's then structured data. And then unstructured becomes sort of long form contract type documents, right? Anything that is really linguistically heavy, right? That really relies on that language information. Obviously the nomenclature is super confusing because you've got that weird nesting definition to it. But it's, people have kind of sliced off parts of the really, really large unstructured umbrella that are addressable. And when you look at the advancement in those technologies, adoption is going absolutely bonkers, crazy bananas. That stuff is deployed really, really heavily. And I think the other thing is that when you look at things that really happen on the unstructured side, on these language pieces, those use cases have historically been so valuable and so difficult to get after. You tend to see them in these really verticalized companies, right? So you'll see a company that just does legal analysis, right? And it'll be a super successful company using these techniques, right? But it's not a generic unstructured data company, right? Because it took them, 2 years to build that model that does that thing. I think that since then, there has been a really big shift. People are starting to realize, oh, wait a minute, I don't have 150 problems, right? I have one problem that is, how do I do unstructured stuff, right? It was actually really funny. After we did our big announcement, Clarify then came out as, the other unstructured data company or whatever they called themselves, like 2 weeks later. So it's interesting where you've seen it addressed in a lot of part pieces. And now, because the technology has kind of advanced so far that it is significantly easier to take up some of these modeling techniques, and enough people have seen these really dramatic successes, people are like, oh, wait a minute, this is actually kind of one problem set that you can address with a unified technology stack.
Yeah, that makes a lot of sense. And just so I make sure I'm understanding correctly, what you're kind of saying is unstructured data is this realm of non-tabular information, let's just call it that, right? And it's image, audio, text, any kinds of things like of that nature, which is a lot of use cases. And in a lot of companies, the way that such unstructured data has been solved and that you've created business value with is by focusing in on some narrow part of that question, right? So something that comes to mind for me is a company like Flatiron Health, where they were working with electronic medical records that were scanned PDFs, and they basically just built a whole architecture of human abstractors that turned those PDFs into, sort of more structured information that they could do machine learning on. And there's countless stories of that in
Absolutely.
a number of different industries. When you say technologies, can you tell me a little bit more specifically what particular things that you believe, that you're talking about? Is it machine learning modeling techniques? Is it more data engineering? What kinds of things are you talking about there?
Yeah, so I'm primarily talking about right now really the modeling piece of things, right? So when we talk about, for instance, what we're using, and this dovetails a bit into the multimodal AI piece, right? We actually use these sort of next generation, like mutant X-Men language models, I might call them, right? But the idea is that when you look at a document, and this is it's not only true of documents. Documents just happen to be, an amazingly valuable use case, and like everyone knows what it is. You might at first think that a document is text, and you would be wrong. We thought documents were text, and we were wrong. That's how we know. And the way you find that you are wrong is that if you look at someone who, say, processes invoices for a living or reads contracts for a living, you take your text and you OCR it and you show them, the OCR of that document, right? They can no longer do their job. And I don't mean their job is now difficult. I mean, literally, without that visual formatting, their job is now ambiguous, right? That document actually loses much of the information that is key for interpretation, right? And that's something that I think people tend to overlook, right? They think, oh, if I'm just good enough at language modeling, I will eventually figure it out. Absolutely not, just not how it works. If you want the most obvious example of this, think about a table that has numbers and nesting, right? There is no amount of language modeling that will account for the differences in read order and nesting that you've got there, right? Not even to mention things like rich text and embedded images, right? That's just like the tip of the iceberg. But that's why, and you've seen sort of this big resurgence now in some of the top some of the top labs like Microsoft and Amazon, right? Where people are using these multimodal techniques. So the idea is you start with this language modeling backend. Obviously, the language understanding is really critical. But rather than just thinking about the linguistic aspect, you find ways of encoding sort of the local visual information, right? The position on the document, right? The position of the document potentially in some larger bundle, right? All of these additional pieces of information. And you get, not just radically more effective models, right? It just works way, way better. But you start to see this really interesting glimpse of the future of ML where, traditionally, text is NLP, right? Vision is computer vision, right? And when you think about a lot of the most compelling cases, like, self-driving cars, anything with video, right? Even if you're talking about simply blending metadata and text, right, in customer chat service, right? Really basic stuff like that. We don't really have the tools to do that today. But these multimodal techniques allow you to kind of take a language modeling backend, tweak them in sort of these point ways. The technique that we use is called model surgery. It's a little bit niche. OpenAI developed it in the Dota bot, but there's other techniques as well, other approaches. That's just what we use to add in this additional sort of structured metadata, which is just it's very, very interesting, and it's been really effective for us.
Really helpful example with the documents, because I completely see what you're saying there, right? It's not just a bag of words. It's actually their structure that's there that is hard. That's just right now, our technology can make it hard in terms of actually applying that structure in a machine learning context. And, one of the fundamental things or challenges that I hear in sort of what you're saying is, okay, on the modeling side, we have an ability to deal and make use of more information than we have before, right? In more creative ways, we have more techniques, we have more powerful networks. But a challenge that I still see in my day-to-day, and I think a lot of people see, is on the data side of that, right? Which is, how do you go? It's cool to hear that unstructured data can be used in machine learning context more, but we still need to set it up, in somewhere that's not just an S3 bucket, or in something that's not just a loose collection of files, right? There has to be some sort of data schema or some sort of structure applied to that, at least so that, perhaps for some analytical reasons, or just because that's more efficient, right? And so this kind of gets us into the question of like ETL and data engineering in the context of unstructured data, which we want to do more, sort of machine learning on. And you were telling us before we started this conversation that those are some areas that have experienced a lot of challenges. Can you tell us about how the data engineering side of some of this unstructured data, some of the challenges you've experienced and how you solved them?
Absolutely. And I'm going to jump as far as to say that modeling is simply not the limit anymore. We have models to be radically effective, right? And I think that while there are obviously people doing great work there, it is very much not the limiting factor. And I think that data is more than anything the limiting factor. And I mean that in a couple of actually really important ways. And this comes down to these questions of ETL and how you handle your data. And in a lot of ways, why unstructured data is such a challenging ETL problem, right? And let's use documents again as an example, right? Now, you've got a scanned document and you have, let's just take a very simple kind of workflow as an example. You're going to OCR it, right? So you use some OCR engine, say OCR engine A, right? And then say you train some classification model that says, oh, this is one of 3 document types, right? And then say each one of those different document types, it gets fed to an extraction model, like a custom named entity recognition model, and then that populates some payload that is structured, right? So, pretty simple, very relatively straightforward. Here is what is really tricky about it, if you were to think about it in a standard flow, right? If I start by labeling some data for that last model, that extraction model, and then I find that the OCR engine I'm using is not very good and I want to change OCR engines. Normally, the way you store that label will not allow you to reuse the label, right? Because the text has changed, the read order has changed, right? Figuring out what someone actually labeled, you can't really do it in a traditional flow. So not only do you have to retrain all of your models, but you have to relabel all of your data. And this kind of dependency mismatch, right? This is something that you see all over the place in unstructured data. And because unstructured data, you can't effectively put strong constraints around your distributions, you can't really change them. And so an example of how you can help that problem, kind of get around that problem, is thinking about sort of the most flexible possible way you can represent your information. So for instance, what we do here in this case is say, okay, when someone labels a particular value, rather than say we're just going to index into the string of that document, right? You have both the string of that document and the position of that information, because again, it's multimodal information, right? And then what that allows you to do is if you ever switch OCR engines, right, you can actually then reconvert that label back into the text format that, that's what you need for training. And so that's a kind of simple example, right? But you see this, I think, all over the place, and you're going to see it a lot more when you come up with this notion of changing the way that you want to do supervision, right? And I'll kind of like throw one other notion out there that I think is really key in all of this. And this is something that Microsoft has been championing a lot recently, called machine teaching. And that's the idea. And, I kind of said modeling is not the limiting factor. Then what is the limiting factor, right? And even frankly, transfer learning models today, they can learn on incredibly small amounts of data, right? However, you need pretty good data, right? And importantly, you just need consistent data. And it turns out this is the thing that's really, really hard for folks, right? Is that the way that we tend to structure these ML problems, if you think classification, like binary classification of Twitter sentiment, right? They're actually very far from how humans think about the problem, right? And historically, we see 95% agreement or whatever on binary Twitter sentiment, and we're like, more voting, right? Have more people vote at it, right? But it never really gets better than that, because the problem is actually not with people disagreeing. The problem is with the framing of Twitter sentiment as binary positive negative, right? It's like that framing will only get you so far. And then you think about more interesting framings, because I think everyone sort of parses the sentence the same way. So you think you can kind of move in the other direction and make some of that reasoning explicit, have people be like, oh, here is the, whatever parse tree that I'm actually using to read through this sentence. These are the positive aspects. These are the negative aspects, sort of like aspect-oriented sentiment, right? In a basic kind of way. But thinking of that as a sort of explicit supervision that a user would provide. So yeah, I think that's a really interesting trend, and it has some interesting implications for ETL.
Yeah, I think the particular quote that you have around like changing the way you want to do supervision, I think that's a huge lesson, I think, that I'm seeing happen right now. And I think it's funny how this happens. I think the way this happens in companies, it's not, somebody saying, okay, guys, we're going to go from supervised learning to unsupervised or something like that, where people are applying like rigorous definitions to the kind of technique they're using. They're saying, hey, these are the fields that we have more confidence in. These are the fields we have less confidence in. We need to get more data for the stuff that we have less confidence in. How do we do that, right? What are the techniques that we can apply on the modeling side? What are the things that we can do from a data collection and sort of cleaning side? That's the way that these changes happen sort of incrementally, at least in my experience. And
Yeah, no, they absolutely happen incrementally. I think I love the fact that you mentioned that people don't use supervised and unsupervised consistently. I think it's absolutely correct, and I actually think it's a problem with the terms, right?
Right.
It makes it sound like they're alternatives to each other. They're really not, right? Any modern system, you're doing supervised learning on top of unsupervised learning. That's just how it works, right? They serve just fundamentally different functions.
Right.
Yeah, I like to think of it more in terms of like a data spectrum. Is like you want to have, this bedrock foundation model of a lot of unsupervised data, just like here's what the world looks like. And then you've got some sort of proxy tasks, right? I call sort of silver standard data, things that are probably directionally correct, or like summarization is a great example of like, you can't come up with a good summarization metric, but you can say this is a better summarization or worse summarization. And it's sort of this pyramid, right, of less and less data as you get closer and closer to the actual problem that you're trying to solve. And everyone knows in practice, like you're always dealing with less gold standard data than you want, but you can like pad that out lower on the pyramid.
I think that is a good segue into what I wanted to talk about next, which is synthetic data and the role of synthetic data in MLOps. And you had mentioned, let me just grab my notes. You said this before we started recording, which I thought was a fascinating term. Some people look at synthetic data as this perpetual motion machine. I love that mental imagery, but explain to everyone what exactly that means for you.
Absolutely. And I just have to remember which daemon I'm thinking of. I think it's Maxwell's daemon. But there's so many of them, it's hard to, yeah, it is Maxwell's daemon, right? So this is a famous physics thought experiment, and I promise it's relevant. And the idea is, the second law of thermodynamics obviously is very important. The idea that you can't just kind of make free energy out of nothing to make it very, very kind of simple, or, things tend towards entropy without external energy. And the idea is that, okay, say you've got two joined containers, right, that have gas in them, right? And now the way that temperature works vaguely is that fast particles, that's higher temperature, slow particles, that's lower temperature. And these particles, these are gas molecules. So the way the idea goes is, say you had a daemon, Maxwell's daemon, that then operated this door in between the two chambers and always let the fast things in one way and always let the slow ones in others, right? And the idea is basically then, because you've created this temperature separation, right, you can get work out of that. And so you've kind of created this energy from nothing. So the idea is, how have you done that? What is the problem with that? And the answer, which it turns out is super fascinating and interesting, right, is that the information processing done by that daemon, when it looks at the particle and tells whether it is fast or slow, that actually has an energy cost, right, to make that decision, right? And that is how it balances out, and you don't actually get it for free. But one of the really key pieces is that they show that energy and information are there's an equivalence there. And the same way that you can't create information out of nothing, you can't create energy out of nothing, or vice versa. And I think that's why I love the analogy of the perpetual motion machine with synthetic data. And to be clear, synthetic data has some really important uses, and we'll talk about those after this. But I think people importantly sometimes have this notion that because synthetic data looks to us like real data, that you must be able to, by creating more and more of this synthetic data, improve, the model's understanding, right? Say, hey, make me more chairs, feed the chairs back in as more training data. But it turns out the only thing that you end up doing is reinforcing what the model actually believes, right? There's no net new information added in that process. And it's an important, but actually a pretty subtle point. And the same kind of fundamental issue actually plagues a lot of areas, right? If you think about the generic active learning task, and this is something a lot of people aren't aware of, active learning has actually failed to reject the null hypothesis. Which, let that sink in for a second, right? It's like no one can actually prove definitively that active learning works. Right. And it's like, we've all seen the papers, right? There's tons and tons of active learning papers, right? And you can get active learning to work on any data set, right? And it's this really weird paradox. And it turns out that actually the thing that's really key is the way that you set active learning up on that data set, what I would call human overfitting, right? Where you see what happens on the data set and then you tweak your hyperparameters, you tweak your active learning, right? That is the information flow. That is the overfitting. And that's why you can get it to work on any use case, while at the same time, you cannot violate, you cannot reject a null hypothesis, just with a generic active learning approach. So
just so I understand that real quick, you're basically saying, I kind of see what you're saying with the information energy. You can't just make it up out of thin air, right? And it has to represent something, it has to cost something. But on the active learning piece, you're basically saying that by just, by feeding pieces of data that we know that machine learning model is failing on, we're engaging in a form of human overfitting.
Well, let me, there's an important line in between the things you said, right? Because you said, we know it is failing on, right? And that's actually what's most important, is you don't know that in an active learning context. If you learn that and say it has failed on this example, then it's actually not active learning anymore, right? Then you've just labeled the example, right? So that's actually the key delta, right? Is that in active learning, we must rely on this proxy for was wrong. Uncertainty sampling obviously is the most common one, right? And uncertainty sampling will sharpen all of your decision boundaries. It will not tell you if you have the wrong decision boundary. And it turns out that, in practice, as often as you want to sharpen a decision boundary, you want to change a decision boundary. And, obviously, you can't generically fix that, but at the same time, for any given problem, a given problem will have a reasonable trade-off between sharpening and exploring. And you find that for the given problem, it will work for that problem, just not generically.
Got it. It's helpful. I think one of the most helpful things for me in my machine learning journey was taking a theoretical machine learning course that I really didn't do very well in, but really taught me in terms of how to think about distributions and modeling, what it is you're actually trying to model, right? And what sort of information it is that you're trying to gather in order to then, predict in the future. And I think what I'm hearing from you, is a lot of intuition around that. And what I would love to do is talk about how that intuition plays out in production systems, right? Because
Absolutely.
I think, right, where the challenge happens is these systems, they get to scale, you're dealing with millions and millions and millions of data points. You're dealing with so many different, features that people start to lose that underlying intuition. And then they just say, okay, the next model refresh will just do better, right? We'll do better on some metrics. And then, 10 months from now, we look back and say, wait, the data drifted, the model drifted, and our metrics are down, right? And so can you talk a little bit, it could be in terms of synthetic data, or could be a little bit in terms of multimodal data or multimodal machine learning. How have these lessons around thinking about information and data played out at Indico? And
Absolutely.
what are some examples?
Yeah. So, and there's obviously, there's a couple of things wrapped out in there, right? I think one of the things that's really key that we recognize is that the user with the best understanding of the process is the person best situated to train the model, right? And this is something that a lot of people miss. I think it's not usually how organizations are set up. Is often it is the data scientist's responsibility to teach the model.
Yeah, absolutely.
And I think actually the theoretical ML course that you talked about, actually, I think that's much closer to what I would assert is sort of the proper role of a data scientist. The proper data scientist, I think, is going to be most effectively deployed designing experiments, deciding, okay, what metric is actually important for us to track in this context. I think that the world where a data scientist is primarily feature engineering or doing hyperparameter optimization, again, modeling is just not the limiting factor anymore. And I think that is less and less. I think in some cases that is still worthwhile. I think that it is becoming a lot rarer. I think in most cases, data scientists end up doing a disservice by focusing on that. And so we, much more instead we say, okay, look, the goal is to engage the subject matter expert as much as possible, get as much information into the system as possible, right? And then set the data scientists up to basically maintain that system, right? Be the architect really of how this plugs together, right? And that's an important separation, just thinking about who has what information at what point. I think another piece, and I'm going to kind of point at Tesla's version of active learning here, because I think it's a clever way they get around that paradox of active learning, right? Because still it is useful. You still do often want to sift through, which labels are useful, which examples are useful to label and not. But you have to add information into that system, because as we've established, like generic active learning, it just won't work. And the way that Tesla does this is that they actually have a human in the loop active learning, not in the way you think, where, of course, a human labels it downstream, but they have a human operator decide which active learning candidates actually get labeled, which is sort of interesting, right? We think of this notion of like a weird example as like weird to the model. But what they have found, and from a theoretic perspective, you inject information into the process by doing this in quite an effective way. They say humans are much better at evaluating what is a weird example and what is not. Obviously Tesla had quite a lot of success doing this, so I think that's strong evidence that they're correct, and I think there's good theoretical justification for why that's a good approach.
So I wanted to touch on something that you also mentioned, which was data flows and infra flows, and information flows. And it seems like you kind of were talking about that, where you want the right person doing the training. Is that what you were hinting at when we mentioned that beforehand?
Yeah, so that is another really key piece. Actually, the term I used earlier that I think is very useful here is human overfitting, right? And I think this is an information flow that people don't think about very often. It is one of the key reasons I think information flows are such a helpful way of thinking about ML systems, is that when you as a user look at the results on your test set, right, and in some way change your model to improve that, that is an information flow, right? That is overfitting. Even though it wasn't done by a machine, even though you put a human in the middle, right? It is still overfitting in the same way. Now, it happens subtly, right? And it happens over dozens and dozens of generations. But I mean, we've all been there, right? Oh, tested at 3.4, tested at 3.5, tested at 3.6, right? And I think no place can you see this more clearly than the way that Baidu gained ImageNet back in the day, right? Where they were literally just bending over backwards to try to get what was it, 5 or 10 extra test set runs a day, and obviously it had a dramatic impact. But we set things up in a very kind of definitive one-way flow, and we think it's at the same time it's very important to focus on quality of the data and consistency of the data, because models will not fix a broken process. They will only replicate a working process.
This has been a really, really interesting discussion, I think, because of the observations that you've made about how data needs to be set up. And where I'd really love to take this conversation next is in talking about the specifics, maybe an example case of how Indico has done this. I think a lot of our listeners in the community, I'm sure that they're listening to this, and I know I am. I'm listening to what you're saying and I'm thinking, okay, how do I manage my own system, based on the lessons I'm learning, right? And what am I doing that maybe I can change? And I would love to kind of make that a little bit more tangible and talk in a sense of an example of how Indico is doing it. So maybe we can start with what does a typical client for Indico usually look like, maybe in terms of industry, size, or use case?
Yeah, so we're Fortune 100 kind of BFSI firms. We do broader stuff than that, but say contract analysis or something along those lines, right? Or actually, let's take annual statements. Just maybe more folks will be familiar with those. They're slightly visually rich documents where folks are like, here's how things work for the year. And the idea is that the customer says, hey, we've got some tasks, some extraction that we want to do from this, right? And we want to find someone to help us do this extraction. And we say, okay, great. Get us 200 of these, right? We're going to help you actually label these 200. That becomes sort of the experimental setup, and show you how well this works, right? But fundamentally, the idea is they get the product in their hands, right? They label the 200 examples in. They kind of label, say, here is the information that we want extracted. The model is automatically trained in the background and then sort of pops to life and turns that motion of data extraction into this AI augmented approach. It's highly kind of composable and configurable. So the idea is you've got the model as an API, right? You've got this interface for the labeling, right? You've got upstream and downstream data hooks, right? You can plug these into message queues. So, folks will do things like grade, like a contract in Salesforce, inject it back into their Salesforce UI, right? And then maybe they do a correction of the extraction in Salesforce, but then they're sending it back to Indico to do the actual model update.
Okay, got it. So it's like basically, I'm a subject matter expert, as you put it, at the bank. I've gotten access to Indico's data set. I take my annual statements, I drop them in, I do some labeling, and voila, I have sort of a model that's sitting in the background, but the API that I interact with is basically just taking some particular inputs in the future, whatever fields in that annual report that I'm interested in modeling, and gives me the outputs that I want.
Yeah, exactly. And then, obviously you've got a lot of configurability for exactly how you want that process to flow.
Okay. And when you say like configurability in terms of the process, does that mean that, okay, now I'm the analyst that has, another batch of 1,000 reports that I want to then, do the sort of extraction on? How do you guys usually recommend that process? Because I think it's interesting. We talk a lot about productionization. This is productionization of like a machine learning model solution.
Yeah, so it's actually the way that we kind of refer to it is staggered loop. So the idea is that there's not really a distinction for us in the way that we operate, right? So you load, even it might be easier to think you loaded 1 million documents in at the start, right? And say it's 1 million documents, you're going to be adding 1 million documents to that every year, right? Because I think that's more typical to how folks work. There's some bandwidth that they've got to process at.
Okay.
You pick it up, you start labeling, and you're like, okay, this is the stuff that I want to extract, right? And then, as you kind of continue working through the queue, right, that data is automatically fed into a model that is helping you label faster and faster and faster, right? And then, you've got configurability for like, hey, for this field, whatever, just like send it through. I don't even want to look at it, right? And the corrections generally will then get fed into a staging model. So the idea is at some point you say, okay, like this is good enough for us to work in production, whatever. This is like 80% faster than it was before. We're just going to start using this, kind of cut this as our production timestamp. Then the corrections, just as you go, they all get fed into the staging model, which is, it starts as a copy, but then, learns this additional information. And then you sort of opt in to an advancement. So that's why we call it staggered loop. Closed loop, terrible idea for 1,000 reasons. You do not want that data feeding back into the model. It will screw your model up, and then there is no method of recovery, and everyone is sad. And so that's why we kind of use that, and not to mention the fact that it's just like a compliance nightmare. So people then opt into the advances, or sometimes we'll say, hey, we added 1,000 data points, it didn't improve. What happened? Oh, hey, Johnny has been labeling wrong for the past month, kind of thing.
Okay, so I'm starting to understand then how like your subject matter expert is empowered via machine learning and this AI augmentation, right, for their workflow, and how that machine learning model sits in the back end and is gradually sort of improved without them needing to write a single line of, sklearn or TensorFlow or whatever. That makes sense. But in this workflow, I can't imagine that every user that you work with is particularly sophisticated with machine learning and think through something like data drift, or think through something like, maybe, they're dealing with annual reports in 2019 and 2020, the format changes, those kinds of breaking changes happen all the time in machine learning systems. In my context, healthcare claims change formats from payer to payer. How do you guys deal with that?
Yeah, so they don't have to deal with it at all. When I was describing the staggered loop, right, as it goes in through production. So one of the things that's really key is that older techniques, if you're relying really heavily on some aspect of those formatting, they break. They break hard when things drift. Actually, modern techniques, you don't have that issue nearly as much. You've got a lot of historic variability where you start. Obviously, you never want to train on just one variant of a document. That's like, yeah, I know folks do that, especially with templated stuff, but that's exactly why you don't want to do that, is because data drift then just breaks things. So, when we're talking 200 documents, we're talking 200 random documents from the past, decade, right? And then that gives you a huge amount that, when you see a new format, it's not going to hard break, right? You do see data drift, but that turns it into sort of this gradual thing over time, which then means that by incorporating it into your staging model over time, it's not a problem, right? So long as you then, you can decide how often you want to look at that staging model and flip it over to production, because that's what's going to capture the data drift. Folks usually don't need to do it for like years because it starts, but it takes 5 minutes if you want to. We find folks often do it like monthly or quarterly or something.
Okay, got it. So basically what you're describing is almost that the Indico tool encapsulates a process in terms of thinking about data into models, into model versions and improvements and deployments.
Absolutely.
Yeah, I love that, what you were talking about earlier, and that idea of like models won't fix a broken process. They're only going to replicate a working process.
Got it. Yeah. And I think this is a nice lesson for us to all kind of coalesce around, because a lot of times what I think in the community we talk about is process, right? And how the process differs at different companies, given the needs, compliance could be a need, security could be a need, or just, our product is a little bit more complicated than something else. And that's what makes the process of building and tuning and deploying machine learning models hard.
Yeah, and I think there's just maybe one other note there, which is that I think a lot of times people don't recognize the cost of making a bespoke change to your ML model, and this is exactly the case, right? If you did anything at all to your model that was specific to the prior version, right? Any specific ETL process, right? That breaks really hard. Right. And then when you've got the new version, everything falls apart. So that's one of the things that's really, really key, is that the way that our process works, you are not allowed to do that. Right. You're not allowed to apply custom like ETL processes to this workflow. Right. You can do, end processing for like what gets presented to the human. But that's the only way that you actually can allow this sort of automatic upgrading to happen. Right. Otherwise, you need a data scientist to look at it every single time. When you look at these systems where you've got 1,500 regexes, you're like, oh, well, it works really good for X. It's like, yeah, but no one knows how it works. And if things change, you will never recover it.
So is it fair to say that your perspective on the modeling question is to kind of almost put the model in like a lockbox and say like, don't touch this unless, you know, the data flows are kind of clean?
Yeah, I think that's absolutely right. I think that, you know, people often think about model understandability and explainability as like, I should be interrogating model weights. I think that's the absolute wrong way to think about it, for 100 different reasons. I think the best way to think about it is that these are programs that we are commanding and directing with data. And so the explanations that you are looking for are in your data. They're not in your model. And, you know, in the model, you're just chasing phantoms, right? When the data actually has the answers.
That's really cool. I really like that way of thinking about programming data rather than programming models, because at the end of the day, that's the real input, right? It's not,
It is.
you know, whether your layers are, you know, you have 9 versus 10, it doesn't really make a difference unless your data really is you know, is correct, is consistent, as you've put
Yeah,
it.
and it goes back to the whole idea of synthetic data and how just throwing more synthetic data at it isn't going to fix the problem. Although you may think it will.
No, I mean, there's this joke, right? Which is if you have 24 hours to build a model, right? How do you do it? How do you build the best model? You spend 23 hours labeling data and 1 hour building a model, right? And that's the answer. And I think a lot of people, like, they'll spend like years trying to figure out how to get out of labeling 50 data points. And it's bonkers to me.
That's a great point, honestly, also, because as a machine learning engineer, I have been feeling lately that I have been criminally underexposed to data engineering. And like now I'm spending all my time like learning the history of databases and like learning like how different like data warehouse systems and everything, because like that's where all the action actually is, like this notion of the modern data stack. And, you know, I completely agree with your notion that the modeling part, it kind of feels like, you know, it feels like you know, the upside there has been limited.
It's not the limiting factor for us. That's how I talk about it. It was the limiting factor for us several years ago. Today, the models are so sophisticated and capable that data is our limiting factor, right?
Yeah. And you know what? I'm going to go so far. Go ahead, Demetrius.
It's funny though, too, because NeurIPS is packed. That like conference gets a lot of attendees. And it feels like the shift is happening, especially as more and more people are talking about it. We've interviewed quite a few people on here who are trying to scream from the mountaintops that this is a thing. And then you have Andrew Yang, who's obviously making a lot of waves talking about these kind of things. But there's something inherently interesting. It's like a dog with a bone, data scientists and models.
Yeah, I mean, it's very rewarding and very fun to watch the number go up. But I was really impressed with OpenAI's summarization work recently. They were kind of like jumping on board with this notion of like, hey, look, what did we create? It was a new way of doing supervision, and it was awesome.
That's really cool. I'll have to check that out. I have one last statement to make and one last question. I think the statement being, I think, you know, we talk a lot in the community about machine learning engineering and how it differs and is similar to software engineering, right? And, you know, if you think about it, I think, you know, maybe the future of this whole thing looks like, you know, software engineers continue to deal with code and machine learning engineers are data programmers, right? Where they're thinking about, they're applying the mindset of a data scientist in terms of interrogating data and thinking about data, but then using the powerful and sort of expressive tools that software engineers have available. And those kinds of tools are coming out now, you know, as this whole production ML and MLOps movement moves forward.
Yeah, I totally agree. I think the data scientist of the future is, you know, a data architect first, even.
That makes sense. Yeah, they're people that are designing data intensive systems with a strong sort of statistics.
Yeah, because the statistics and like how the training flows and how the information flows, I mean, that is just as important as what database you're using.
Right. So we're coming up on time here. This has been a great conversation. And I think just the last question I'd really like to ask is, you know, with your wealth of knowledge, your experience, like building sort of data intensive systems in a number of different contexts using unstructured, structured data, and with where you see the field going, what would you tell a machine learning engineer in 2021 who has sort of a mountain of data, but is kind of trying to understand like how to go about, you know, building a system that can be robust, scalable, and reliable. Like, what advice would you give to that person in terms of what to focus their time on?
I would say that the number one thing to focus on is making sure you've got a good problem definition. And what I always say is people want ML to be like a genie that shows up and is like an oracle that does everything perfectly. Even putting aside to the fact that that's not how it works, imagine it did work that way. How would you know? That's always what I tell people. It's like, how would you know that it did that, right? So you need to start with good, consistently labeled data, right? And then the second thing that I would just say is like, recognize that these are really big, enterprise grade, difficult systems to put together at sort of the very edge of what is possible from a compute perspective, right? You cannot do it as an individual person in an enterprise, right? Maybe like as a startup kind of demo thing, perhaps, but it's recognizing that it is not trivial that folks will, a demo is really, really easy to stand up, but, we see folks take 3 years from demo to production. And those are the lucky ones because they get to production, right? Like look at the failure rates, like the failure rates are real. They are cautionary tales, and just, you need help to do it well, I would say. And so look for help. And there's a lot of help out there, I'll say as well.
Awesome. Fascinating, man. This talk has blown my expectations way out of the water. I don't know what I was coming in here with, but it has gone above and beyond. That is for sure. And I thank you, Slater. There were so many gems in here, and I am so happy that we got to geek out on this stuff. It is something that I was not expecting. And next time, hopefully, I will not be as jet lagged and I can hold my own a little more. But I think Vishnu did an awesome job. Vishnu, you got any final comments before we sign off?
I mean, I just want to say thank you again, Slater, for joining us. To everyone in the community, I would say, like, these are really interesting lessons about unstructured data, your experiences in terms of like making data useful to machine learning systems that I would love to hear your thoughts on the Slack, in the discussions channel, in the MLOps questions answers channel. And a quick shout out to Slater's Twitter, his website, blog. You can find him online. Slater, is there anything else you'd like to say to the community in terms of where they can find you or what to talk to you about?
I was lucky enough to grab slater.website, and so I'll try to put a blog post up here soon. No, I mean, look, thanks so much for having me. It was a total pleasure. Like, right back at you. Tons of fun, right? And jet lag sometimes make conversations more interesting. So I hope it's as good, when you look back at it.
Yeah, awesome. This has been really cool, man. I appreciate it. Everyone that is still sticking around, check out Slater's stuff, give us a like, a subscribe, add a comment or a review wherever you are listening in on. And we'll be back next week for another coffee session. Thanks, y'all.